Hello, everyone. I'm Einstein Millan. I'm a software architect of WhitePrompt, and today I will be discussing Introduction to Transformers in Natural Language Processing. So what is an OTT? An OTT is an effort by WhitePrompt to share things that we've learned, things that we've researched into, and that we're interested in with others. So if you haven't already, subscribe and give us a like. Oh no. So a brief introduction. I went over it in my last presentation, my last OTT. Just a brief overview of what natural language processing is. And the definition is just that it's a field of artificial intelligence that focuses on the interaction between humans and computers through natural language. And the goal is to enable computers to understand, interpret, and generate human language in a way that is both meaningful and useful. So why is it important? Communication facilitates the interaction between humans and computers, making technology more accessible and more efficient. Another area is data analysis. It allows computers to analyze vast amounts of text data, and it helps us by providing insights to complex problems. And applications. It powers many of the applications like virtual assistants, chatbots. It helps us with sentiment analysis and much, much more. I'm going to go a little bit into the popular natural language algorithms and models. Some of them are not as much of a hot topic as they used to be. These are a few of the ones I could find, or they may not be as popular nowadays. We have a bag of words. We have TF-IDF, which I must confess, I don't know what the acronym means. And then we have word embeddings. And particularly for this conversation, word embeddings is interesting because it gives us insight into the transition from word embeddings into the newer architectures and models, such as the GPT model and the other popular models nowadays. So, and basically it focuses on representing words as vectors in a high dimensional space in order for us to capture as much meaning and relationship between a corpus of words. So there are deep learning algorithms, and for those of you that don't know, deep learning is a way to mimic how the human brain processes information. And this usually makes us think of neural networks, which is one example that we see of the deep learning models. We have the recurrent neural networks. And this one is basically, if we go 10 years into the past, we'll notice that we see the Google Translator as an example of recurrent neural network. And then we have long short-term memory, which kind of attempts to solve some of the limitations that we would see in recurring neural networks, which I'll discuss in a little bit. And we also now have the transformer models, which is the topic of this conversation, which is a groundbreaking architecture that focuses on self-attention mechanisms to process more efficiently. And this is where we touch upon BERT and GPT. And so how is this different from the previous models, and why is it groundbreaking? So let's look a little bit into transformers and the previous architectures and their limitations. And we have recurrent neural networks. They were revolutionary in their time in their ability to handle large sequences of natural language and natural language processing, but suffered from vanishing and exploding gradient problems. So they were very difficult to train. And then we had long short-term memory and the great recurrent unit. These architectures improved upon recurrent neural networks, but processing sequences, them being sequential, prevented them, as you could see in the text, from parallelization. And this would limit the speed at which we could model things. So this led to the birth of the transformer models. the transformer models were introduced in the seminar paper. I can post the link if you guys wish. And it was released in 2017. And the aim of the publication was to tackle the limitations of the previous models. The transformer architecture discards the sequential nature of the recurrent neural networks and instead uses attention mechanisms to weigh the relevance of words in an input sequence. So this means that words can directly connect to another, resolving long-term dependencies in a more effective way. And so what does this mean? We have the thing with human interaction between computers and humans is that humans speak a high number of different languages, and each language has its own context and its own word ordering and its own meaning in the way we portray things. So this architecture allows the computer to see a large corpus of words and assigns indexes to each word in order to know in which order the word appears, and it's able to relate one word to the rest of its context. And depending on whether we're talking about BERT or GPT, GPT is more backwards conscious, whereas BERT is more symmetrically conscious. It can both predict as text is coming in, and it can derive meaning from past words. It doesn't mean that BERT is better than GPT or vice versa. It just means that they have different applications and different use cases. So how does this impact? What is the impact of these transformer models? They have a vast impact, as we could see from ChatGPT in the field of natural language processing. It delivers state-of-the-art results in many tasks, serving as a foundation for subsequent models such as GPT and BERT modeling. They process large text very quickly due to their parallelizable nature, and they've improved upon the handling of context and word dependencies in a sentence. And this takes us to one of the most important aspects of the transformer model, which is a context vector. It plays a central role in many natural language processing models, particularly those based on transformer architecture such as BERT. So as you can see, it's bidirectional, and GPT. In these models, each word is initially represented by an embedding vector. The embedding vector lacks knowledge of context. It's typically trained on a large corpus to capture semantic and syntactic information. This initial representation is static and it's context independent, meaning the same word has the same vector no matter where it appears. So regardless of whether the word is used in different texts, it will always have the same vector value. It doesn't take into account its surrounding corpus. However, as I said previously, these static word vectors are insufficient to capture the complexities of language because many words have different meanings in different contexts. And that's where these context vectors come in. The transformer architecture processes the input sequence in such a way that the final representation of each word is a context vector that takes into account specific context in which the word appears. This is done through a mechanism called self-attention. I put some lower level knowledge here. I don't know if this is worth mentioning, but I'll show it for a few seconds in case someone that watches this YouTube video later wants to delve a little deeper and see the more engineering and scientific aspect of the architecture. Okay. This is the one bullet point I could not include. So let's go into self-attention. It's in self-attention mechanism, each word's initial embedding vector is updated by taking a weighted sum of all the word embedding vectors in a sequence. These weights reflect the relevance of each word to the word being processed. This way, the final context vector for a word reflects not only just its own meaning, but also the meaning of the surrounding words. Excuse me. This is particularly useful for handling words that have different meanings in different contexts, like bank in the riverbank versus bank account. I was looking for the example, but this is a very, very easy example, so to speak. And for capturing long-range dependencies between words like cat and the cat chased the mouse into the corner because it was hungry. So it's able to capture this whole meaning. Overall, the context vector is a significant advance in natural language processing that has led to the more sophisticated language models such as GPT and BERT. So here's a little bit of information about BERT and GPT and who they were developed by. And here are some of its strengths and weaknesses and ideal use cases. So I think this is the more relevant part of the piece of information in this slide. Transformers perform exceptionally well on a variety of NLP tasks, such as text classification, sentiment analysis, named entity recognition, and machine translation. However, they require substantial computational resources and training data. Understanding and debugging these models can also be challenging due to their complexity. Also, depending on specific tasks, certain transformer models can be more appropriate than others. For instance, BERT's bidirectional understanding is useful for tasks that need deep understanding of context, while GPT's autoregressive nature is beneficial for the required text generation. So this is, I was talking to the team before this talk about this, and this is something I mentioned. Everyone's onto the hype of ChatGPT, and they want to incorporate this into their projects and technologies, but we should really evaluate which models work best for each case. So about data transformers, there's a few types of data transformers. Today we have scikit-learn, which brings its own transformer API. And the rest that are listed up here are mostly for theoretical knowledge, if you want to know where things come from. But this is so advanced, and it's such an quickly evolving field that most of the stuff, like models and not models, but the tools to create these models and to tweak them are already bundled for you in some frameworks and libraries. So some of the data transformers, and usually these are pretty interesting. This is pretty much standard process in natural language processing, and it's a process of tokenization, stop word removal, stemming lemmatization, normalization, and vectorization. So basically, these whole pipelines focus on converting, simplifying, and cleaning up word corpuses such that we can convert this into binary code that the computer can understand and transform into models. So the importance of data transformers, connecting data transformers, creating a pipeline, the iterative process. These are, like as I said, mostly scikit-learn provides this utility, the utilities necessary for these processes. So I won't go into too much depth on this slide. I won't bore you with the details by reading everything out, but it's worth taking a look at this if you want to understand the iterative process of creating these models. And also to have a basic knowledge of machine learning, to know how to work with data and to model, how to model it, how to do feature engineering. Here are some of the practical applications. of the transformer models. We have sentiment analysis, translation, question answering systems. This is really important, super groundbreaking in my opinion. Text summarization, so it's something that's able to generate summaries of long pieces of text that it can give you everything in layman's terms. Very useful as well. And text generation, which is what we see in GPT. So what I would like to suggest as a recommendation is that when you think of generation, think of BERT, and when you think of when you think of context understanding, think of BERT, and when you think of text generation, think of GPT. So here are some of the challenges and future trends for the field. Computational resources. Storage is not a big deal anymore, but CPU usage and memory are expensive. So that has to be taken into account. Clients should be aware of this. For developers, engineers should be aware of this when attempting to tackle these problems. Interpretability. So given the complex nature, it's hard. The models are hard to debug and to understand why we get results, the results that we get when we're working with them. So definitely domain knowledge is very important. Data is another challenge. Gathering large amounts of data is a challenging task. Making sure that the data is cleansed, and in a way that the pipelines can understand, the data pipelines as well as the machine learning and learning pipelines can understand. And the problem of bias. Training data is the models are being trained by humans, and humans are prone to bias. So this sometimes makes it into your models, and it's always good to have a team of engineers that can sanity check each other. Future trends, efficiency. So there's ongoing research into creating smaller, more efficient transformer models that maintain high performance, but are more accessible and environmentally friendly. Explainability. So right now, tools are being developed to improve the interpretability of the transformer models, helping users better understand the decision-making process. Few-shot learning. So with the advent of models like the GPT-3, we're moving towards models that can perform tasks with just a few examples or less data, and reducing the need for labeled data sets. So think of unsupervised learning, more unsupervised rather than supervised learning. And mitigating bias. Researchers are focusing on identifying and mitigating bias in transformers to ensure their fair outcomes. So they're developing software tools to help us with these challenges. So a brief recap. The presentation covered the basics of natural language processing and the role of data transformers in preparing data for natural language processing tasks. We looked at the rise and importance of transformer models in NLP, examining their structure, functionality, and popular instances like BERT and GPT. We discussed the connection between data transformers, transformer models, emphasizing the necessity of a robust pre-processing pipeline. And we explored the various practical applications of these models, as well as the current challenges and future trends in the field. That's it. I hope you enjoyed the chat. I hope I didn't go into too much detail. I think sometimes going a bit too deep can be boring, but let me know if you have any questions.
Hey, I have a question. I think it's more on the shallow side of the field. It's not as deep as the research you showed, but you mentioned like entity detection. So people can use like ChatGPT to detect entities in a given prompt. And there's like libraries. There's a Python library called Core, which you initialize the OpenAI client, you pass it into Core, and you pass it in a text, and it extracts like the the name of a person. It's very interesting how it takes natural language and gives you a JSON. So you can store and use like you would using Python. What do you think is the role of this prompt engineering? Because that's basically what Core does. It gives the large language model a special prompt that says things in a certain way that makes the AI generate the text in the way that you want. So it's really on the shallow side of this. It's not a research scientific thing. It's on the side of, I'm going to tell the AI exactly what I want. And if you can do that, or use a library that automatically does it for you, you get some pretty interesting results. Core is one example, and there's also LangChain, which helps you build bots with memory, like memory summarization. And it's the same concept. It's like prompt engineering to tell the LLM what is it that you want, and it's like many layers of abstraction. So do you see prompt engineering being a topic that's useful for developers to learn?
Definitely. I mean, you brought it up and I wasn't aware of it. So thank you for that. That's actually very interesting because I think it sounds like that's where this field may be headed. I want this. You choose the domain area. You choose what tools, if this is a mathematical subject or if this is a field of medicine, what pipeline or where should I go with this? And we would end up with something like Jarvis, at least in my mind.
Yeah.
So
yeah, and the big challenge is, like you said, it's not easy to debug. So you're going to make a prompt, but you don't know that every user is going to get the same response because you delegate it to the AI. So it's not the same as developing code. You're trusting a lot in the model for this.
Yeah, definitely. Yeah, thanks for that insight. I think that with the new tech talks that we're having, and with the way things are moving, the way things are moving forward in the industry, we have a lot of topics that we can discuss. That'd be very interesting to keep us, on the leading edge of technology. So definitely worth discussing in our new tech talks what you've just mentioned.
For sure.
Definitely something I want to keep going with, continue with these talks about natural language processing, because I see a lot of our clients are very interested in these areas.
Marcelo, can you share the name of the first tool you mentioned? Core?
Yeah, I'm going to put in the OTT channel the link.
Okay, thank you.
Awesome. Any more suggestions or questions? Going once, going twice? Well, I was hoping to have something more related to the actual transformers that we all like, the Optimus Prime, but this one was pretty interesting too. And they're both artificial intelligences. So we're getting closer. I hope everyone has a wonderful weekend. Thank you for attending this talk.
Thank you, Einstein.
Yeah.
Take care.
Thank you. See you guys.
Thank you.
Yes.